cement using Recurse needle apparatus. Later on, with this standard consistency value, we will perform initial and final setting time of cement. And this experiment, standard consistency of cement, follows Indian Standard 4031 Part 4. In my first experiment, you have seen the soundness test of cement by Leach-Atelier's apparatus. On that experiment, I had to add some quantity of water, and the quantity of water was the quantity of water was 0.78 P into weight of cement percentage. So on that experiment, the water quantity was 0.78 P, and that P is called standard consistency of cement. And today we will find this value. Now see the apparatus which we will use in this experiment. First, see, this is a gauge trowel. Here is our grease for oiling the mold, and here is our cement sample. This is our distilled water. And here is our balance. The main part of this experiment is called Recurse apparatus. Now see the main apparatus used in this experiment. This is called actually Recurse apparatus. This apparatus consists of a mold. You can see here a mold having 70 millimeter diameter top. Its top diameter is 70 millimeter or plus minus 5 millimeter may vary, and its bottom diameter is 80 millimeter plus minus 5 millimeter may varies, and its height is 40 millimeter. And Recurse apparatus, this part is a metallic base and this is a frame. This is a frame, and another part here, this is a movable rod. This is a movable rod attached with a cap. And here you can see a metallic pin for blocking this movable rod. And here is a needle portion and scaling portion. You can see total 0 to 40. Here is marking total from 0 to 40. 0 to 40 mm. And another part of this apparatus is this container. This containers actually we have to fill hydraulic oil before experiment. Now the other parts to conduct this experiment is we will use stopwatch, and here you can see this is a enamel tray for mixing cement and water. According to Indian Standard 4031 Part 4, to conduct this experiment, we have to take 400 gram cement and we have to add some quantity of water, but there is no fixed value for mixing the water, or we cannot say that this is a fixed value for consistency of cement. We have to find out in this experiment of standard consistency of cement. Here we are taking suppose 29%. Here we are taking standard consistency, means P 29%. Now we will take the measurements. First, set the enamel tray on the weight balance, and first set 00 by pressing this button. Here is written tier 0 enter. When you will enter, while you press this button, then the reading will be 0. Now we are taking 400 gram cement. Okay, nearly 400 gram. And now we will measure the water quantity. You can see this measuring glass, total 500 ml capacity, and you can see here each small division is 5 ml. Here is written each small division is 5 ml and total capacity is 500 ml. So we will take 116 gram. Here is 105 ml. Now we measure 116 gram water. Okay, now we will mix this cement with water. And keep in mind one thing very carefully. Before mixing water, you should do all the arrangement. Means first you have to oiling this mold and the top surface of this glass blade and the needle, which is called standard consistency needle, or you can say it plunger G. Plunger G also need to be set here. Here you can see this is plunger. This is a plunger for standard consistency test. This length is 50 millimeter. You can see this length is 50 millimeter and the diameter is 10 millimeter. It is a 10 millimeter diameter. Okay, now we will mix cement paste with water. Keep in mind, before mixing water, you should on the stopwatch. Now I am starting stopwatch, and here I am adding water. So here our paste is ready, and you can see the timing. Now it is 3 minutes 39 seconds. And be careful, we have to do this whole experiment, to make this paste, we have to do this within 3 to 5 minutes, not less than 3 minutes, not greater than 5 minutes. Now fill the mold. Level the top surface of the mold properly. You can do it with the help of a spatula. This is called spatula. Now shake the mold like this way to expel out the entrapped air. Okay, actually one thing you should have done previously before filling the mold. First, set the needle at 0 position. Here you can see 40, 30, 20, 10, 0 from the bottom of this mold. You can see here the needle end point is not directing to the 0 line. So we have to adjust . Okay, now you can see now the indicator point and the 0 line is exactly coincide each other. So, remember these things. Before filling the mold, you should set the needle at 0 position first. Okay, now our whole arrangement is set. Be careful before doing the experiment. Fill this container with the oil, machine oil. Okay, now we are placing this mold on the top of this base plate. Now be careful and do the same what actually I am doing here. Exactly do the same. First pull it up up to the end point, up to the cap. Now unblock the metallic pin. Look, now release it slowly. Here I am releasing, downing. Here is just stop here, because at this point you can see at this point this needle basically touch the topmost surface of this paste. In that position, allow the needle to penetrate freely. Now release your hands. Now see the reading. At what point it will be fixed? Okay, almost it is fixed. Now you can see here is reading 21 millimeter, 21. But according to Indian Standard 4031 Part 4, for consistency of cement, the penetration value from the bottom of the mold, from the bottom of the mold should be 5 to 7 millimeter. Means, see here, from the bottom of this mold, from the bottom is, where is the bottom? You can see the top surface of this glass. Top surface of this glass plate is our bottom surface of the mold. So, from the bottom of the bottom surface of the mold, the penetration depth should be in between 5 to 7 millimeter. You can see here reading is 0. Here is our 5 millimeter, and then 6 and 7. So when our needle will come to this position, then we will say the standard consistency is okay according to Indian standard part 4031. In this experiment, your penetration value is 21 millimeter, which is not elapsing with 5 to 7 millimeter. So in this case we have to add water. We have to add water so that the needle can penetrate more. In this case we are adding 4% water. We are adding 4% more water. So the total quantity of water will be 29 plus 4 equals to 33%. So the 33% of 400 will be 132 gram or ml. Now we will measure 132 ml water. Okay, there is total 132 ml of water. Now again we will wet 400 gram cement. Add water and start the stopwatch. Mix it properly within 3 to 5 minutes. Our mix is ready. Now fill this mold. Place the mold. Hold this cap and do the same thing. down, 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 stop, and allow the needle to penetrate. You can see now the penetration value 5-6 mm. Perfect results. Come to the calculation portion. Look at this table. Look at this table. First, fill this all things. Date of sampling, say 3/5/2021. Date of testing, today. Cement brand and grade. OPC 43 ACC brand. Batch number and date. Sampled by, say, group 1. This experiment is basically error and trial basis method. Look at this table. Weight of cement in trial 1. Actually, we have done total 2 trial here. In trial 1, weight of cement 400 gram. Weight of water was 116 grams. So percentage of water mix was 29%, and the needle penetration was 21 millimeter, and duration of time was 3 minutes 40 seconds, say 4 minutes. In our second trial, weight of cement 400 grams, same. Weight of water 132 grams, and percentage of water mix was 33%. Needle penetration was 6 millimeter, and duration of time, say 3.5 minutes. See, in our first trial, we found 21 millimeter as a needle penetration, which is so far from 7 millimeter. Keep in mind one thing: if your needle penetration value is more than 7 millimeter, then simply add more water. And if needle penetration is less than 5 millimeter, then decrease the quantity of water. In our first trial, we found 21 millimeter needle penetration and water percentage 29%. And in our second trial, needle penetration is now 6 millimeter, which is lies in the ranges between 5 to 7 millimeter. So our consistency of cement will be 33%. Now, keep in mind one thing: in this experiment, actually we have done total 2 trials, but you may have 3, 4, 5 or more trials. In our first trial, we assumed 29% water, but in trial 2, we added 4% of water more. But you have to do this in a total 3 or 4 trials. Like, do the trial 2 by increasing the water by 2% from 29 to 30 or 31% in trial 2. Then do the trial 3, 32 or 33% of water. So in our experiment, our final result is 33%. And from here, we can define the definition of standard consistency of cement. We can define it in two ways. In physically, we can say minimum quantity of water required to make the paste perfect. Means the quantity of water should be like such quantity so that each and every particle of cement can react with water, and the final paste should gain some viscous force. Another way, in technical term, we can say the quantity of water should be like that at which the needle fails to pierce or the needle fails to penetrate the block between 5 to 7 millimeter from the bottom of the mold. This is technical term. So last one important thing I am discussing here. Sometimes if you do the same experiment with same cement sample in a different weather condition, then the value of standard consistency may vary in different weather condition. That's why according to IS 4031 part 4, it is mentioned that the room temperature during the experiment, during the whole procedure, the room temperature shall be maintained at 27 plus minus 2 degrees Celsius and relative humidity is 65 plus minus 5. Okay, thank you. See you in the next video.